Hello everyone, this is Unofficial Sando. Welcome to the series for preparation for coding interview. Today I'm going through Leetcode 1727, logic submatrix with rearrangement. If you like these videos, you can support me by subscribing my channel or click likes buttons in video below. You can find the complete video list in video description below. Let's look at the problem description first. So we are given a 2D matrix, then we can randomly, not randomly, but we can free to swap the whole columns with all the columns. Then we also can return the area of the largest submatrix, which every element of the submatrix 1. So in the first example, the best solution is to swap the column 3 with column 2. Then this is what we get, and the largest submatrix including 1 is the board matrix here. So in this example, the largest area is 1, 2, 3, 4 is 4. Then in the second examples, we're given a 1D matrix. Then basically we can swap this blue one with yellow one, and then swap this purple one with this one. It's coming to this matrix, then the largest area is 3. Next, let's go to the solution. I call this solution is using some greedy idea, or maybe it seems like this method also use some kind of simulation how we swap the columns. Here is a solution. We going to iterate row by row, then we evaluate the matrix from the initial row to the current row. For example, if we start with row index 0, so this row, we're only looking for this part of the matrix. We have helper array here to record how many ones for these cells and its upper cells. Then, for example, if we have look in the first row of matrix, we will have this array, which means for these cells, it has 0 ones. And for these cells, have only 1 cells because in the upper, it doesn't have any elements. And for this one, it's 0 as well. Then what we are going to do is we do the sort from the highest value to the lowest value for this array. Then we obtain 1, 0, 0. Basically, what it means, we always want to swap the largest columns with the largest ones into the first elements, and the second largest is second. Then next, we will going to evaluate. So basically, if we do the 1, 0, 0, which means is equally, it's like for the first 1D matrix, we sort, which means we swap the second column to the 1. So we get it's 1, 0, 0 matrix. Then for this case, of course, the largest area is 1. So we will update the max area variable. And for the second columns, because itself is 0, there's no way to get a submatrix from including these cells. So we cannot get any valid answer. The same for the third columns. Then we come into the next row. Basically, we are looking the submatrix in this area. So again, we record the helper array. So for these cells, it is 1, but it's above elements there's no continuous 1, so it still has only 1. Then the difference is that for these cells, itself is 1 and its upper is 1 as well. So it's coming at 2. Then the same for these elements, same for the first one, it's still 1. So then we sort again, you get 2, 1, 1. Then basically, after we sort, it means like for this 2D matrix, we swap the second row with first row. It's coming 1, 1, 0, 1, 0, 1. Then we evaluate this subtracts column by column. The fourth columns, we only use these cells and its upper one. So of course its area is 2. Then when we come into the second cell, basically we're looking the area is including the first column and the second columns. But its upper is 0, so the only submatrix we obtain is these 2. So the area is still 2 for this submatrix. Then when we go to the third cell, we're looking all the whole 2D this 2D matrix, but because it's upper and the second column upper is also 0, so the only submatrix we can obtain to include these cells is this one. So now this area is the current largest one, is 3. So we obtain the max area 3 here. So finally, we come into the last row. Again, we will formulate our help array. So for these cells, each cell is 1 and its upper is 1, so it's 2. And for these cells, these upper cells have 2 1, so it's 3 3. Then this cell is kind of special. Even so, his upper is 1, but because his self is 0, so we will put it 0, because there's no way to formulate the submatrix which including 0 cells, right? Then after we obtain 2, 3, 0, we sort again to have 3, which means we swap this column with this column, so we got 1, 1, 1 at leftmost, and the 0, 1, 0, 1, 1 have in the second columns. Then we evaluate column by column again. From these cells, we just build a submatrix including its cells and its upper one. It doesn't have any left column, so the maximum we can obtain is 3. And we won't counting all the cells in the matrix. Basically, we just use this one as its height, right? So then multiply its width. So the width is 1. Then for the 2, for these cells, we are looking submatrix for this area. Since this one is 0, so we only get these 2. Then the way to calculate that is it's the same. Use its height 2, multiply the width. This 2, right? So it's 4, which is our final answer. Then for the later 0, so since there's no way to build a submatrix including 0, so we just skip it. So yeah, so that's how we come the max area is 4. So next, let's look into the code. So into my implementations, I get a row number, total column number. I build in the help array as a 1D matrix column by column. So using the column number, and we have global max area to record the largest area. Then first for loop, we iterate by row. Then we build in the help array by iterate all the columns first. If it's 1, so we adding 1 into the help array. So one thing to be noticed that the help array here also recruit the previous ones. So we don't need to look into the say upper row again. We just directly adding 1 here if it's equal to 1. Otherwise, reset to 0. So then I just sort this array to get a new array. I will use it for next for loop. The next for loop is how we evaluate column by columns and calculate its area, right? So if the current cell height is greater than 0, basically this which means the current cells is not equal to 0. So we got the max area of the max area and its area, right? Its area is basically its column index plus 1 is, then this is the width, and multiply the height. Then eventually we got the maximum area. So the way I'm saying here using greedy idea is because we also trying to utilize the height most in the left. Then once we evaluate more later columns, basically we trying to maximum the width. This is why we want to solve the helper array here. In terms of the computation complexity, we had one for loop outside, so we have big of n here, multiply how many operations in the next loop. Then here, J loop, we have m operation. This is m as well, but this here is the most costly, is cost m log m, so we take the maximum one. So in general, it's like big of n multiply m log n. In terms of the space complexity, we create a helper array here, so it's big of n. Of course, there's a way to reduce the space complexity, which is to just directly write into the matrix as using the helper array value. But here, just for more readabilities, I'm choosing to have a helper array here. Okay, that's all about today. If you like my videos, please comment and let me know any problems you want me to explain further. And see you in next video.